The Juno mission is the most far out use of solar cells to power a space mission to the outer planets. The Spectralab powers over 300 space missions. A lot of what we build is for Boeing. We powered the first telecommunications satellite. We had the first cells on the moon. Our cells power the space station. We have stuff crawling around on Mars. Solar cells, the ones that people are probably most familiar with are the flat plate silicon that some people have on their roofs or that power street signs and stuff. The way flat plate silicon cells work is you start with a semiconductor material that's photosensitive, which basically means that when sun shines on it, that's going to be enough to get the electrons moving, where they collect and transfer out to, your signpost or your house or wherever. Those typically are about 20% efficient. What we do here are mainly multi-junction solar cells. The difference is this one has really 3 solar cells in one, grown in very thin layers on top of each other, layer by layer, atom by atom, which make it more efficient. The reason you might use solar to power spacecraft is they're fairly lightweight. They're not as risky and costly as nuclear, so they end up being the best economical trade. Juno was built here and it's on its way to Jupiter. It gets there in 2016. It's going to take a lot of measurements of Jupiter's atmosphere and its magnetic fields and sends all that data back to Earth. Based on the success of the Juno missions, there's talk of maybe using solar cells to go even further. When I see pictures of little rovers and the International Space Station, I kind of get choked up. I'm part of that history. That's really cool.